In this video I'll be looking at the solution to the June 2010 paper question 8 of the Edexcel D1, and the topic of the question is critical path analysis. The question starts by describing a figure which is looking at an activity network. The activity is represented by the arcs on the network. The number in the brackets are, as usual in these questions, are the time, in this case in days, to complete each activity. And each activity, we're told, requires one worker. And we're trying to work out the way in which the project can be completed in the shortest time possible. We're asked to complete a diagram in the answer booklet to show the early and late event times, and then in part B of the question, following on from that, state the critical activities. And then in a grid on the answer booklet again to draw a cascade, sometimes known as a Gantt chart, for the project, and to use the Gantt chart to determine a lower bound for the number of workers needed, and then saying why we think that that is the lower bound. So taking these then one at a time, the first question is a standard what's called forward pass and reverse pass through a diagram to write on here the early and late times. So starting off the early times, we begin with the first one with 0, and from there look at all those events that can be reached from that starting event, and putting in there the longest path to those. So for looking at activity A, leading to that point gives us 4, and then well, we have to be a little bit careful with B, because you'll notice that here there is a dummy activity in here, so it's not 2 at this point but 3, which needs to go in here, and also a 3 for C. Again, looking at the dummies working forward from there, from the 3, then activity E is 6, and that gives us the greatest value there of 9. And going from the event at the bottom with 3, we can work forward to the 13 at the bottom, and then keep moving forward in this way, being careful to keep track of the dummy variables. So, but if we look at event, so activity F, then we can see there we've got 3 and 9 is 12, but the dummy here would make it a greater 13, but there's also the path which comes via this point here, and that is also of length 13. So we get to here at 13. The top event is 11, that's the 9 plus H, giving us there a total of 11. The 11 plus 5 gives us 16, just checking the dummy activity in there again, but that's not going to make any difference to that one, is because it would give us 13, so the longest path to here is 16. And then finally that 16 plus 6 is our longest path to give us 22. Working backwards in a similar way, we're this time looking for the shortest paths to each point. So working back from the 22, taking away 6 for L gives us 16. And so the 22 minus the 3 would be 19, but that dummy variable in here means that we have to take that into account. So in fact the shortest path, the smallest value there, is 16 rather than the 19. So the latest time we could start this, get to this point here, is 16, because we've got to go to that dummy activity to get to the 16 bus. So be very careful with these dummy activities, they can make a big difference. But working back in a similar way, we find that each of these is as follows: 9 there at the top, the one at the bottom here is 16, again because of that dummy activity going in there, and then working up here, these become 3. The top one here, just checking that one, 11 take away 5 is 6, and the 9 with the dummy activity is 9, but we want the smallest of those, so 6 and 3 in this point here, and finally back to the start 0. The critical activities then, well, we check through the diagram. The critical activities are those that are joining events with times which are equal to, where the early time and the late time are equal. So the critical events, if I just mark those in first of all, we can see that I just mark a red dot at each of these, and finally at the top there, 11 and 16 and 22. Now if we work then through the path, it should be that the values there, 22 minus the duration of each activity, gives us the time at the event before. So here we go through the activity, just tracing it through. We're not asked to mark the critical path on our diagram, however I will do. And then it comes down this dummy here and then via C. So looking at those in turn, the critical activities are C, E, H, J and L. The marking for this part of the paper was to first of all give an M1 and A1 mark for the forward path, and then another M1 A1 mark for the reverse path to the diagram. So 4 marks for getting those correct, and then just a single B1 mark for obtaining the critical activities. The next part of the diagram asks us to take our diagram and produce a Gantt chart or cascade diagram. So what I've done is reproduced the answer to the first part of the question here, and you can see I've already marked in the critical path. So the critical path or the critical activities will always go usually on the top line of our chart. We then add in those that are left, for example A here, with its duration of 4 and its early startest time, which in this case is 0, coupled with the latest time, which is 6. So A starts off at 0 and we indicate it with a duration of 4, so a block of length 4. You could actually write in the values A4, but then just a little indication that in fact it could go up to time 6. So rectangles of the correct length, and then showing what's called the float time after that. So taking these one at a time, B can also start at 0 here, it's length 2, duration 2, and it has a float time of 1 because it could finish as late as time 3. D is the next one to look at. D can start at 4, so D could start at this point here, it's length 5, so 1, 2, 3, 4, 5, just marking that in, and it must finish by latest time 11, so it has a float there of 2, so it could take us up to a total of 11, which is this point here. And we just keep working in a similar way. F could start at time 3. It has duration of 9, so that would get us up to 12, just marking that in. And it has to be finished by time 16, so a float here of 4 this time. Just a few more to do. G also can start at that time of 3. It is length 10, so could be finished by time 13. And has a float of 4, beg your pardon, so it has to be finished by, no, it is 3, it has to be finished by 16. I just note there's a slight error I've put on my diagram there. I said F of duration 12 on my diagram. What I meant, of course, is duration 9. I, if we look at I, it can start at 9. It must be finished by 13 because it's of length 4. So I can start at this point here. It's duration 4, so it must be finished, or could possibly be finished there by if it is on time. However, there is a float also of 3, so bring us as well up to 16 here. And finally K, the last one, could start as early as 13. It is duration 3. But has a large float on it. It needs to be finished. Sorry, I beg your pardon. Hasn't got. Yes, it has in fact got a large float on it. It is up to 22. So it must be finished by the end of the project. So there we are. That's our diagram finished. It then goes on and says, what's the minimum number of workers that are going to be required for this? Now, this is a case of taking what's called a timeline and moving it across the diagram. So if I draw a line in here, I'm trying to work out how many workers are required at any one point. So if we take this line, you can see that if I put it in that position, for example, then there are 3 workers needed at that point. But we can move through, and if we continue on through the diagram, we can see at this point here that we will in fact have 4 in total. So that's 1 on the critical path E, but then also D, F and G must be happening at that point. Even if we move them within their float time, D, F and G are all happening at that time. So on day 9, then each of those must be happening. Therefore, we must state that. We've got to justify our reasons, so we can say that on day 9, E, F, beg your pardon, D, E, D, F and G must all be taking place. Now this is the largest number, so therefore 4 workers are needed as a minimum. The actual mark allocation for this part of the diagram was actually quite complex in terms of how you get these, but there was a method mark for getting at least 10 of the activities correct, and then answer or accuracy marks for the critical path at the top, and then 2 more depending on how many of these that were correct. So 4 marks there, and then finally for the last part of the question there were 2 marks, both of them B marks, so no method as such there, but a good explanation for stating the 4 workers was 1 mark, and then a good explanation of why you reached that conclusion. Well, that's the end of that question. You can find answers to other questions at www.furthermaths.org.uk.